Hello.
Yeah, I've started the recording. You can share your screen and you can present your topic
Okay.
whenever you're ready. Then the video will be sent off to YouTube.
Okay. Is it visible now?
Yes.
Mm. So, good evening, everyone. Myself, Riddhi Joshi, and my today's topic of presentation is the future of space travel, our interstellar destiny. So, let us first start with why we should go to the stars. First thing, the Earth faces long-term threats such as asteroid impacts and the eventual expansion of the sun. Becoming a multistellar species is humanity's ultimate insurance policy for survival. Second is resources. Growing population increases the demand for resources. Our galaxy contains vast reserves of minerals, metals, and potential energy sources. This will sustain human civilization for millennia. The third one is driven by the curiosity of humankind, the curiosity to discover and explore the galaxy and the space beyond it. First thing is that we are most interested in learning about other planetary systems and galaxies up close. Second is discovery of new laws of physics and the answer to the ultimate question that are we alone in this universe? In-person investigation of planet with science of light will be a monumental achievement. Then let us dive into a brief history of a grand idea. Before 1950s, interstellar travel was just a fantasy, but after 1950s to 70s, projects like Orion and Daedalus came into picture. This project proposed the idea of using nuclear explosion or robotic probe to propel the spacecraft to study the interstellar space. Our first step towards the um, exploration of the interstellar space started with the launch of Voyager 1 and 2 in 1977. While they will take tens of thousands of years to reach another star, they are our first emissaries to the galaxy. Now let us speak about the current advancement, the dawn of the new era. First one is Breakthrough Starshot, an ambitious project to send gram-scale nanocraft to Alpha Centauri. Second is the use of propulsion system. Many propulsion systems such as nuclear propulsion system, light sails, etc., are being used for propelling the spacer using powerful lasers to push a ultra-thin light sail to 20% the light of speed of light, cutting the journey to approximately 20 years. And the third one is the advanced materials. Materials like nanomaterials or self-generating materials are more efficient for making equipment that can be used in space, such as spacecraft and spacesuit. Breakthroughs in nanomaterials are making light sails lighter and more efficient. And the last one is the fusion research. Private companies are making real progress on compact fusion reactors, a potential game changer for propulsion. Now let us speak about how to cross the void. Theories for interstellar propulsion. First one is beam energy. Light cell and electron beams are a new concept for potential larger probes. Then the second one is a fusion rocket, continuous high efficient thrust for large crewed mission. And the third one is the antimatter propulsion. It is the most powerful potential fuel source, but technologically immense and complex to generate. The fourth one is speculative concepts such as Alcubierre warp drive and wormholes. These techniques are physically not possible due to lack of technology developed yet, but these are theoretical basically a very good topic of research. Now, the challenges which we face for doing an interstellar space travel. The first one is tyranny of distance. The nearest star to our galaxy is Alpha Centauri, which is 4.24 light years, and which will take 75,000 years with the current technology to reach there. The second one is the impact shielding. With the relativistic speed, even a dust grain is like a bomb and can damage the spacecraft. Third is the radiation. Protecting crew and electronics from such high cosmic radiation is important as it can harm the spacecraft as well as the crew members. Last one is communication and autonomy. An 8 plus years communication lag with Alpha Centauri means ships must be fully autonomous. Now let us speak about the first destination which we could land if we are possibly able to get into the interstellar space. That is Alpha Centauri. Alpha Centauri is a three-star system which is closest to our galaxy. A potential habitat which is found over there is Proxima Centauri b. It is a Earth-like planet which has capacity to have a water, but the planet faces intense radiation and stellar phase from its stars. The goal for reaching there is by using a flyby system. Initial missions will perform high-speed flybys to gather the space first ever close-up data of an exoplanet. Now, the road ahead, future work and development. The first development which will be necessary for making it a reality will be the maturing our propulsion system like using laser sails and achieving controlled fusions. The second one is life support, developing full closed loop system for multi-generational journey. Third is addressing hazards, creating advanced shielding for radiation and impact. Long-term visions such as conceptualizing world ships like the Charles project to tackle the social and ethical challenges. Uh, most of the space agencies are planning for the future space travel. NASA has various programs such as Voyager program, which is already providing us direct data from interstellar space. The second is NIAC, which is NASA Innovation Advanced Concept Program. They give funding for the far future ideas needed for interstellar flight. And the third one is the long-term planning. A conceptual mission to Alpha Centauri for 2069 is being planned through guided technological goals. Now, ESA, the European Space Agency, also has such missions such as Comet Interceptors mission, a mission capable of visiting an interstellar object passing through our solar system. Now, let us conclude a journey. Interstellar space travel is a journey of generations. The challenge is now one of the engineering problem rather than being a physics problem. This goal can be reached through the hard works of multiple generation. The collaboration is a key. Success will require unprecedented global cooperation for making the fantasy a reality. And the first step for having an interstellar space journey would be the work that we do today, which is a crucial first step on our journey to the star. Thank you.
Okay, that was great. Thank you. It was really interesting. So we have the recording. It will be sent to YouTube so more people can actually hear your presentation. And also, you will receive a certificate for creating this and being able to share your passion with us. So,
Mm.
yeah, thank you so much.
Thank you very much.